Introduction. Newton's law of cooling or warming states that the rate of change of the temperature of a body is proportional to the difference between the body temperature and the surrounding temperature. The model is expressed as d capital T over dt equals to k capital T minus capital T m. Subject to capital T, T0 equals to capital T0 and capital T, T1 equals to capital T1, where capital T, T equals to the temperature of the object at time t. Capital T, M equals to the temperature of the surrounding object. D capital T over dt equals to the rate of change of the temperature. Next, capital T minus with capital T M equals to the difference between the object's temperature and its surrounding temperature. And lastly, K equals to the constant of proportionality. The equation 3.5 is solved by separating the variables and integrating both sides of the equation. Integrals 1 over capital T minus capital T m dt equals to the integrals k dt. Ln capital T minus capital T m equals to the kt plus c. Capital T minus capital T m equals to the exponent power of kt plus c. Capital T T equals to the a exponent power kt plus t m, while a equals to exponent power of c. The general equation of temperature of the body at any time is capital T, T equal to A exponent power of KT plus Tm. Find the specific solution with the exact value of A and K by applying the condition given. Capital T, T0 equals to capital T0 and capital T, T1 equals to the capital T1. Problem statement. A body of temperature 80 Celsius is placed in a room of constant temperature of 50 Celsius at time equals to 0. At the end of 5 minutes, the body has cooled to a temperature of 70 Celsius. A. Find the temperature of the body at the end of 10 minutes. B. When will the temperature of the body be 60 Celsius? And C. After how many minutes will the temperature of the body be within 1 Celsius of the constant 50 Celsius temperature of the room?
Okay, so first question A. Let T be the temperature of the body at any time T. Then dt over dt equal to k in bracket T minus 50 subject to T0 equal to 80 and T5 equal to 70. Okay, solve the differential equation by use the integration method. Okay. Integrate 1 over T minus 50 equal to k integrate 1 dt. Then ln T minus 50 equal to kt plus c. Then we move ln to another side. We get T minus 50 equal to e power of kt plus c. We separate e power of kt with ec and assume that a equal to e power of c. So we got the general equation T equal to ae power of kt plus 50. Okay, the next step is to apply the condition given to find the value of a and k. First, T0 equal to 80. We substitute 0 into the equation. ae power of 0 times k plus 50 equal to 80. Then we get a equal to 30. Okay, to find the value of k, we substitute t equal to 5 into the equation. So 30 e power of 5k plus 50 equal to 70. Then e power of 5k equal to 20 over 30. We move e to another side. We got k equal to 1 over 5 ln 20 over 30. So the value of K is negative 0.08109. Okay, the equation describing the temperature of the body at time t is T equal to 30 e power of negative 0.08109 T plus 50. Okay, to proceed with equation A, substitute T equal to 10 minutes into equation 4. Okay, T10 equal to 30 e power of negative 0.08109 times 10 and plus with 50. So we got the solution, we got the answer 63.33 Celsius. Okay, so for question B, T equal to 60. Okay, then 60 equal to 30 e power of negative 0.08109 T plus with 50. So e power of negative 0.08109 T equal to 10 over 30. So we move e to another side. So T equal to negative 1 over 0.08109 ln 10 over 30. So the value of T is 13.55 minutes. Then question C. Since the temperature of the body within 1 Celsius of the constant 50 Celsius temperature of the room, so the temperature of the body should be 51 Celsius. Then we calculate 51 equal to 30 e power of negative 0.08109 T plus with 50. So 1 equal to 30 e power of negative 0.08109 T. So we move to another side to get the value of T equal. So T equal to negative 1 over 0.08109 ln 1 over 30. So the value of T is 41.94 minutes.
From the solution, it is found that the temperature of the body after 10 minutes is 63.3 degrees Celsius. This result is derived from Newton's law of cooling, which explains that the rate of temperature change is proportional to the difference between the object temperature and its surroundings. The time taken for the body to cool to 60 degrees Celsius is 30.55 minutes. And it takes 41.9 minutes for the temperature to be within 1 degree Celsius of the surrounding temperature. To slow down the cooling process, the body should ideally be placed in an environment with a temperature closer to its initial temperature, as this would reduce the temperature difference and slow down